4-point charges QA equals 2 microcoulomb, QB equals minus 5 microcoulomb, QC equals 2 microcoulomb, and QD equals minus 5 microcoulomb are located at the corners of a square ABCD. Find what is the of side 10 cm. Find the force on 1 microcoulomb charge placed at the center of the square. So we must find the force this fellow, which has a charge 1 microcoulomb, experiences because of the 4 forces that are placed on A, B, C and D. So this 1 microcoulomb, I am writing it as 0 or O, whatever. And this 2 here, I am going to mark it as 1. This is going to be 2. This is 3 and this is 4. I am doing it like this so that you won't get confused and it would be more easy to solve the questions. Now write this down, this is important, okay? The diagonal of a square. The diagonal of a square is a root 2. Here a root 2 and diagonal of a square is a root 2 and A stands for what? A stands for the side of the square. Here the square has a side of 10 centimeter and hence the diagonals AC and BD will be 10 root 2 centimeter and AO equals BO equals CO equals DO will be having the side as 10 root 2 by 2, which is 5 root 2 centimeter. We will need this, we will need these sides for calculations, which is why I have written this for you. Okay, don't write this in your exam paper, just write it aside so that when you go through the question you will understand how you got 5 root 2 and all those stuffs. Okay, now coming on to the main part. So we have to find the force experienced by 1 microcoulomb charge placed at the center. So first let us find F01, which is K into Q1 Q2 by R square. Here Q1 is 2 microcoulomb, Q2 is 1 divided by R square. This is going to be AO, right? This is AO, so that it would be 5 root 2 the whole square, which is 2K by 50. K by 25 is the force experienced here, F01. When it comes to F02, it is K Q1 Q2 by again 50. Now here it is going to be K by 10. F03 equals K Q1 Q2 by 50 R square, which is K by 25. For F04 also it is going to be K by 10 itself. Okay, now see this here, K by 25, K by 25. F01 and F03 are having the same forces, K by 10 and K by 10. Here also they are having the same, F02 and F04 are having the same forces. But now let us look at their directions. Are their directions same too? We will check it. F01, see F01, 2 microcoulomb and 1 microcoulomb. Both of these are positive charges. That is, they are like charges, right? See, plus sign here, like charges. Like charges will repel or attract, like charges will repel each other. So when I'm standing here, this fellow, when I'm standing on this O position, since both of these charges are like charges, they will repel. I will not go towards 2 microcoulomb, I will go away from 2 microcoulomb, right? And this is F01. Now here, this is the direction of F01. Now let us find the direction of F02. This is 1 microcoulomb, this is minus 5 microcoulomb. One positive, one negative. They are unlike charges. What will unlike charges do? Unlike charges attract each other. So I will go towards him. I will go towards minus 5 microcoulomb. This is the direction of F02. Now the direction of F03, see, 1 microcoulomb, 2 microcoulomb. Again like charges, repel, go away. This is F03. F04, I am sitting on O and I am seeing, see, 1 microcoulomb, minus 5 microcoulomb. They are, one is positive, one is negative, so they are unlike charges. What will unlike charges do? Unlike charges will attract. So I will go towards minus 5 microcoulomb. This is my F04. So I've got the directions here, right? So now I don't know if you have observed this, but look at this. There's F01 and F03. I told that both of these are having same forces, right? F01 and F03 are having same forces. But let us see the direction. See, F01 is acting in this direction. I will mark it here. See, F01 is acting in this direction. F03 is acting in this direction. F01 and F03's forces are same, but their directions are opposite, right? In the same way, if we look at F02 and F04, F02 and F04 are having same forces. Magnitude of the force is same. But see, F04 is in this direction, F02 is in this direction. Again, their directions are opposite. So here we can write like this. F01 and F03 are equal in magnitude, but they are opposite in direction. They are equal in magnitude but opposite in direction. We know that when two forces are opposite in direction, what do we normally do to find the total force? We will subtract, right? We will subtract both the forces because they are equal in magnitude, but if they are opposite in direction, we will subtract to find the total force. We will subtract. So same way I am going to subtract F01 minus F03 equal to 0. Even if you do F03 minus F01, it's all right. There is no problem. Okay. Now F02 and F04 are equal in magnitude, but they are again like the previous case, but they are opposite in direction. So we can say F02 minus F04 is 0. So here what is the total force F net here? F net is 0, F net here also 0. So what can we conclude? We can say that therefore the total force experienced by 1 microcoulomb is equal to 0 Newton. See, that's all. So we found the force experienced by 1 microcoulomb. What is it? It is 0 Newton. There is no force acting on plus 1 microcoulomb. Everything is cancelling out. Okay, this is how you must do for your CBSE Board 12 class exam. Okay, but if you are writing for your JEE exams, you won't get this much time, right? So here just look at the charges. One is here 2, 2. Both the on the opposite sides. See A here, AC on the opposite vertices. As it is the same charge and the sign is also same. So you can make sure that both of these will cancel out. Here and also B and D. See opposite vertices. -5 microcoulomb, -5 microcoulomb. Both are same charges. Sign is also same, so they will cancel out. Be sure. Okay, for such questions, this is how you can do. That force will be 0 if on the opposite vertices you have the same charges with the same signs. Okay, and also remember this, don't write this in for your exam, just I've written this just so that you will understand how we got it. Okay, diagonal of a square is a root 2, and here a is the side for here. So here we have been given with 10 centimeter as the sides, so the diagonal will be 10 root 2, but we are not using the diagonal, we are taking the half of the diagonal, only AO we need. So 10 root 2 by 2, 5 root 2 centimeter. Then we find each of the forces experienced. Then F01 and F03 are equal in magnitude but opposite. We know that when the direction is opposite, what do we do when direction is opposite? When direction is opposite, we will subtract, right? So that is why here I have subtracted. In both cases it is coming to be 0, so total F net is 0. Therefore the total force experienced by 1 microcoulomb is 0 Newton. You don't have to convert each of them into coulomb, because we don't have to substitute these values here, because at last everything is going to get cancelled. Okay, so this is how you do this question. I hope it is clear to you guys, and if you have any doubts, put your doubts in the comments section. I will surely answer it for you. So that's all for today. Check out the other questions, other important previous years board questions. I have uploaded them, so do check them out. And that's all for today. See you in the next class. Bye bye.